So for our program, we decided to do the cookie icing topper. Our problem was that we had to design something that would put a drop of icing on top of a cookie. The cookie should then move to another position where it was placed with the other finished cookies for
Okay, so we had the cookie topper, and our problem was to get cookies sent over and to get iced and have them delivered to be inspected. So we started off with an inclined plane. We created a gravity chute, had the cookies come down. Our second part of it, we used a 3A3 motor to start up a conveyor belt and have the cookies sent over. And then we used a sonar to stop the motor and stop the cookies in place on the platform. Up here we used a 269 motor, and we used a rack and pinion to push a syringe acting as our icing. We used glue. We had the glue come out, and we put a wait time on it so that the glue would icing the cookie. After we iced the cookie, we would have our servo motor flip the platform down into our landing chute to have the cookies inspected.
We built the automated guided vehicle. Here's a picture of the final solution. Our basic challenge, we were supposed to build a guided vehicle that would travel back and forth in a straight line to deliver batches of parts back and forth. One of our constraints that we had was we couldn't use 4 wheels. We had a constraint of 3 wheels. Anything you want to add?
So the program starts with the bump switch, so it's delivering the parts to the other side. And once it hits the tape, it will stop.
The reason it goes back is so it doesn't keep reading the value of the tape.
And every time it stops, it waits for 0.5 seconds. And we're going to hit the limit switch, so it could be the last trip. And the LED flash is going to be flashing, which means that it's going to be the last trip.
And that's the end of the program.
We had the soccer goal. Our challenge was to make a soccer goal that after only the ball would pass through, it would make the light blink for 10 seconds straight. But, however, our constraint was that we could not have a set off from hands or clothing or anything else besides the ball. As you see, we have our flashlight shining down on the light sensor value, so only the ball will set it off. And all you have to do is tap the ball at all, and it'll flash for about 10 seconds. The ball is then kept in the holding area in the back. Basically, it's very hard to get back out, as you can see from the small opening. But it also does not get set off by our hands. And that is our thing. Goalpost.
Alright, so we have a cable winding system mechanism. And our problem is we were supposed to make a winding system that was supposed to get a certain amount of cable. It has to do this consistently. Also, one of the hard parts was to make an emergency stop just in case something were to go wrong and to shut down the whole mechanism.
break it down.
So our project was the surgical robot arm. So our problem was a surgical supplier needed a arm that could operate in a closed-off environment where it's sterile environment so that humans couldn't be in there, but you had to operate it from the outside. It had to be able to pick up and move objects inside the sterile environment. Our problems were it had to have 3 ranges of motion. It had to rotate 160 degrees. It had to be able to move up and down, and it also had to pick up objects. So these are some of our sketches. Some of our original ideas were we were going to have a pulley system.
Go ahead.
So, down, over the cube, close it,